question, what we need to look at is some key pieces of information. This plane is banking to the left at an angle of 20 degrees, and it moves in a horizontal circular path. When it says that, that means that in the vertical direction the plane is not moving, so therefore there is a component of lift which counters the weight, which is L cos 20, and that therefore we will not have no net vertical motion. So in vertically the net force is zero. To make a horizontal circular path, the plane just moves in a horizontal circle, and that means that the downward force mg is equal to L cos 20. Now because we've been given m, which is 1200, I can put that in and find the lift. That may be useful later on. Now, horizontally, the force due to the lift is pointing horizontally to the left. I'm interested in the horizontal component of the lift because I am producing a motion that's a horizontal circular path. So there must be a force towards the center that provides that net force. So the net force is L sine 20, and that produces a centripetal force which causes the object to move in a circular path. So L sine 20 is the net force, and that equals mv squared over r. Now in this scenario here, you can find L, and then you plug in L, you know m, you know speed as given, therefore you can rearrange for r. Now there is another technique which I've done, and even if I didn't have and work out L, I can use the mathematical relationship of sine over cos being tan. So L sine 20, this equation divided by this equation, L sine 20 divided by L cos 20, so this equation divided by this is equal to mv squared over r over mg. The m's cancel, the l's cancel, and we get tan 20 is equal to v squared over rg. Plug in the numbers and you end up with 817 meters. So two ways to answer this question. One, find L from looking at the vertical, and then use that looking at the horizontal to find the radius. And note particularly that vertically the net force is zero, that is Newton's first law, and horizontally the net force is a finite value, so there is a resultant, and that's Newton's second law. And using those to be arrive at these two expressions. Without these two expressions, we cannot answer this question. So you must be able to come up with this diagram here, and then these two expressions for you to solve this question.